In 1997, BC 76, we're asked which of the following sequences converge. Now it's very important that you note that in this problem we're not dealing with series, but we're dealing with sequences. And you can usually tell the difference because the sequence is enclosed in these curly braces, whereas the series would have the sigma notation. So sequences are just lists of numbers separated by commas, whereas the series are actually going to add those sequence of numbers together. So in order to tell whether they converge or not, all we really need to do is to look at the limit as n approaches infinity of the expression 5n over 2n minus 1. We know that this converges to 5 over 2. So this sequence converges. If that were an infinite series, the series would not converge because the limit as n approaches infinity, the minimum requirement is that that limit has to be 0, which it's not in this case. Again, the limit for the next one as n approaches infinity of e to the n over n, well, that is definitely infinity. Remember the order of the relative strengths of different function families. E to the n is much greater than e to the x, rather. It's greater than any polynomial function, so that ratio will be infinitely large. For the third one, we have e to the n over 1 plus e to the n. And as n gets larger and larger, that 1 is going to have less and less effect on the ratio there. And so what you basically have is just e to the n. Now, if you weren't sure about this, you could use L'Hopital's rule, because this is infinity over infinity. So you could take the derivative of the numerator divided by the derivative of the denominator and take the limit of that, and we would get the derivative of e to the n is e to the n, derivative of 1 plus e to the n is also e to the n, and there we get 1. So however you look at it, that limit is also 1. Now once again, that is the limit of the sequence. The sequence has a limit. If this were an infinite series, the series would have no limit, because eventually what you're doing is you're just adding 1 for every integer out to infinity. So there's no way there could be a convergent value there. So which ones converge? 1 and 3 converge, but 2 does not. And the moral of this story is, note the difference between a sequence and a series. Sequences can converge to numbers other than 0, but if a series, if the limit of the nth term as n goes to infinity of a series converges to anything other than 0, we know that it diverges. So it's a slight distinction in there, and hopefully that's a little more clear now.